This is a reminder class connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. So we should be in the December 13th attendance ticket. The link is in the chat box along with the password. Please open that up. Please give me a green check. Let me know if you're having any issues getting that ready to go. Okay. All right, Zoe, no worries. So you got all of your data, that's good. Are you up for making your own Google account so that you would be able to do that on a different Google account than your mom's? Let me know if that is an idea. Okay, perfect. Sounds good. So yeah, just go that route, and then you can get that turned in. Cool. All right, guys. So we are doing a game day today. So that's where we're going today. We're doing a review of all of Unit 6. And then tomorrow we are starting Unit 7, which is going to be talking about bonding, starting with electrons, because electrons are in control of bonding. So our unit that we just finished was all about mixtures and solutions, different types of solutions, solubility. All right, so lots of good stuff here. No worries, Zoe. I haven't even taken a look at them yet, so you are totally fine. Looking good. So we're going to go ahead and open up our Kahoot. So we're going to go to kahoot.it. You can either go on your phone or on a computer browser. So phone browser, computer browser, or there is also a... yeah, not exactly, Stephen. There's also a Kahoot app that you can use. When you open that up, it's going to be two-step verification. So you do need to enter the game pin, and then you also need to press the buttons in a certain order based on what you see on the screen. So that's just to double check that you are who you are when you enter into Kahoot. Please make sure you include your name. If you don't include your name correctly, then you won't get credit for it. So make sure you include your name. And then remember, just do your best. As long as you are answering questions, you'll get extra credit. So even if you don't get everything correct, you still get all of your extra credit as long as you do your best and you are answering each question. Yeah, exactly, Stephen. Cool. All right, smiley faces if we're ready. Thumbs down if we're confused about anything, if we don't understand what's happening here. Awesome. I'm seeing smiley, smiley, smiley. Love it. All right, so let me go ahead and open this up for us. Get set up. Perfect. All right, so I'm going to go ahead and share this with you. All right, smiley faces, guys, if you can see my screen. Let me know if you can see everything here. Cool. I'm going to go ahead and click play, and we should be able to get started here. All right, so answer streak, randomized, two-step. Cool. All right, here we go. All right, guys, here's your game pin. Here is the pattern. Remember, it does change after every 7 seconds, so go quickly. You can see names up there. Again, enter the pin, and then you do need to press the buttons in a certain way. So green, yellow, red, blue, yellow, green. If you guys need a private chat, let me know. You can either open one by double-clicking on my name, or I can open one for you. Okay, so if you need a private chat, let me know. Sir Steven, I like it. Cool, guys. I'll give you another 20 seconds to get up here. Let's go, let's go. I love all the snowflakes. Cool, thank you, Zoe. Perfect. So Zoe, Sophia, we've got you in the chats. Blue, green, yellow, red. Go, go, go. Yellow, blue, red, green. Red, blue, green, yellow. Red, blue, green, yellow. Give you another 5 seconds. Awesome. All right, guys, we're going to go ahead and get started here. If you still need to join, the joining information will just be at the bottom of the screen, okay? Stephen, it's to prevent bots from joining. I know it is kind of hard to do. Cool. All right, guys. Awesome, Jasmine. Awesome, Sienna. Perfect. Cool. All right, let's get started here, guys. So again, if you still need to join, it's all down here at the bottom. Okay, so mixtures can be blank separated. Red physically, blue chemically. Mixtures can be blank separated. Red physically, blue chemically. How can mixtures be separated? Tell me. 20 seconds. Go, go, go. Awesome, Sophia. I see yours. Zoe, make sure I see your answer as well. Perfect, guys. Yeah, so mixtures can be physically separated. Remember, mixtures are literally just two different things that are mixed together. They aren't being chemically bonded together. Cool. What's happening on Saturday, Adrian? Oh, we've got Ariana in first, Vega in second, Rachel in third, Diego fourth, and Sally in fifth. Let's go ahead, keep on going. Let's make sure that this makes sense, guys. So yeah, mixtures are different types of matter that are just physically combined or blended, right? You could separate them physically. You don't need chemicals. There's no bonding happening. They're all just separate things. Oh, it's your birthday. Awesome, Adrian. That's going to be so fun. What are you doing for your birthday? Perfect, guys. Let me know how you feel about that, right? Red, yes. Blue, not yet. And yellow, it's starting to. Let me know how you guys feel about that. I don't know, Ariana. You must have clicked real fast. Cool, guys. I need a piece of paper. I need a piece of paper. Okay, cool. All right, guys, let's keep on going. So let's see if we can catch up. Homogeneous mixtures are also called what? Homogeneous, are they called compounds, elements, or solutions? Red compounds, blue elements, yellow solutions. Awesome, Sophia. I see your answer. Zoe, make sure I see yours. Thank you, Zoe. 15 seconds, everyone. All right, cool. Yes, this is going to be solutions, guys. Homogeneous. The prefix homo, does that mean different or same? Tell me in the chat box. Different or same? Different or same? Tell me in the chat box. Yes, it means same, right? So homogeneous mixtures means that they look the same throughout, which means it's a solution, right? It looks the same throughout. Cool. All right, next question. Sally in the lead, then Kendra, then Vega, then Juliana, then Ariana. What are heterogeneous mixtures blended as? Are they uniformly or non-uniformly? So red non-uniformly, blue uniformly. Cool. All right, guys. I see Sophia's answers. I see Zoe's answer. 10 seconds, everyone else, to get your answers up here. Awesome. All right. Yes. So hetero, what does that mean? Tell me in the chat box. What does our prefix hetero mean? Yeah, exactly, Ariana. That's a good attitude to have. All right. What does the prefix hetero mean? Still waiting on some more answers. I got an answer from Michael. No, it's not impossible. Right, guys? Yeah, it means different, right? It does mean different. So heterogeneous mixtures mean that they look different in each spot, right? They're non-uniformly blended. Smiley faces, if that makes sense, right? So the top might look different from the bottom. The left might look different from the right, from the center. Awesome. Cool. All right, let's make sure that this makes sense. Yeah, so Haley, just double click on my name. That'll open it up for you. All right, so homogeneous means it's blended uniformly. We also call that a solution. Looks the same throughout. No visible particles. Heterogeneous means it's blended non-uniformly. It does look different throughout, and generally you can see the differences, right? So 10 seconds, let me know if that makes sense. Awesome. Yes, so I'll open that up. So here you go, Adrian, and then Haley, let me open yours up too. Here we go. Cool. All right, guys, make sure you're answering in the chat box then. Thank you, you four. Awesome. All right, so just again, homogeneous, another word for a homogeneous mixture is just a solution, right? You dissolve it in and it looks exactly the same. The top, the bottom, the left, and the right all look the same. Heterogeneous mixtures, they're non-uniform, right? The top of this part might look different from the bottom. The top of paint, as it separates, will look different from the bottom of the paint bucket. And obviously this gravel, if you take a sample of one set of gravel and a sample in another spot, it's going to look different. Okay, smiley faces again, if that makes sense, just because I had some not yets here. Want to make sure everyone feels comfortable with that. Cool, cool, cool. All right, here we go. So Sally, Kendra, Vega, Juliana, Jasmine, let's see if we can catch up to them. A suspension has particles that will not settle out or will settle out. Tell me using your buttons. Red for will not settle out, blue for will settle out. 50-50 chance. What do we think? Suspension. Awesome. Adrian, I see yours. Zoe, I see yours. Haley, I see yours. Sophia, make sure I get yours. Awesome, Sophia. All right, yes, suspension means they will settle. The way you think of this is the word suspension and the word settle both have S's, right? So suspension, settle. Remember, an example of this would be like if you mix flour in water and then let it sit, the flour will sink to the bottom. Or paint, right? If we let paint sit for a while, it'll separate. There will be like a clearer part at the top, and the dye will be at the bottom, so you have to mix it, right? Anytime you see on a bottle, right, mix well before using it, that means it's a suspension. The particles eventually settle out. Okay, cool. Sally on a streak. I love it. If a flashlight is shown through a colloid, right, will the light disperse, making it glow, or will the light go straight through? No glowing. Think about a colloid. That means like fog. That means like milk, right? What happens when we shine a light through a colloid? Awesome, Sophie. I see your answer. Zoe, I see yours. Adrian and Haley, I see yours. Yeah, milk is what's called a colloid. Yeah, the light will actually disperse among the particles, making it glow. So remember, guys, that milk, right, actually has those fat particles suspended throughout, all right, and they'll stay there permanently. And so what happens is as we shine a light through it, the light will just bounce off of those particles, making it spread throughout the glass of milk, making it look like it glows. Smiley face if that makes sense, right? Again, if you haven't done this yet, make sure you grab a flashlight, even like your phone flashlight, shine it through a glass of milk, and you will see this. You will see it glow. Cool. Kendra taking the lead here. Vega, Sally, Juliana, Sarah following. Does this make sense? Let's go over this. So suspension, visible particles that will settle out must be shaken well. Colloid, on the other hand, it's a uniform one that the particles stay permanently suspended, don't settle, and if you shine a light in them, it bounces off the particles, making it glow. Just like in fog, you will see the light beam, and in milk, you'll see the light beam, right? It doesn't just go straight through. Okay, let's make sure that makes sense. 5 seconds. Give me your answer. Make sure you are clicking your buttons. Cool, cool, cool. Awesome, guys. All right, let's keep on going. Vega on a streak. Cool beans. In a solution, the solute is the substance that. Solute does the dissolving red or is dissolved blue. What does a solute do? Does it do the dissolving or does it get dissolved? Go ahead, 20 seconds, guys. Solute, solute, solute. What is our result here? Awesome, Sophie. I see your answer. Cool, guys. Yes, we totally got this, right? We are on fire here. So yes, a solute is the one that is dissolved. And how do we remember this? What's the way that we remember this? What is the way that we remember this, guys? Do you guys remember our memory trick for why the solute is the one that gets dissolved? Yeah, exactly, Kendra. You totally got it. The word solute is a shorter word, and so it's the thing that we have less of, right? The smaller amount. It's what gets dissolved. Cool. All right, let's keep on going here. Water is called the universal what? Water is called the universal what? Solution, solute, or solvent? Michael, I'm not sure. It should show it to you on your phone, I think, right, guys? Or you just remember what you answered and then you see the answer up here. Awesome, guys. See your answers. Thank you, U4. Water is called the universal what? Yes, it's called the universal solvent. All right, so the solvent is what? If the solute is what gets dissolved, the solvent is what? Tell me in the chat box. Tell me in the chat box. Oh, it does, Ariana. Okay, that's so weird. Okay, I'm not sure, Michael, what's going on, but if you look at the screen and you remember what you answered, that should hopefully help you correct any mistakes. Yeah, it's what does the dissolving, right? It is the dissolver, right? So water is the universal solvent because it's really, really good at dissolving many, many different things. Smiley faces, if that makes sense. It's really good at dissolving many different things. Okay, that's why it's called the universal solvent. Now, a solution would not be the answer because a solution is actually when we have a solute and a solvent together, okay, to make a solution. Cool. Kendra, Vega, Sally, Sarah, Ariana on the leaderboard. 5 players just hit a streak, looking good. Does this make sense, everyone? All right, solution is both a solute and a solvent. The solute's what get dissolved. The solvent is what does the dissolving. Water is usually what we're using, so water is the universal solvent. Cool, 15 seconds. Let me know if that makes sense. Red, not yet. Blue, it's starting to. Yellow, yes. Looking good. 10 seconds, guys. Get your answers up there. 1. Perfect. All right, let's keep on going. A solution with high concentration has blank solute. Less solute or more solute? Oops, I accidentally included the word solute. Less solute, solute, or more solute? Solute. Solution with high concentration. High concentration. What do you think? Less or more? Less or more solute? Awesome, Adrian. Zoe, I see yours. Sophia, I see yours. Haley, make sure I get your answer. 8 seconds, guys. Solution with high concentration. Does it have less or more solute? Awesome, Haley. Yes, it's going to have more solute. Think about when you have highly concentrated Kool-Aid or lemonade or Powerade. Did you put more or less powder into it? Okay, think about that. Tell me in the chat box. Yeah, you're putting way more, right? When you're saying, oh, this is really, really concentrated, you mean that you've put way more of the solute of the powder into the drink. Smiley faces if that makes sense. High concentration means more solute. More, more, more. Cool. All right, guys. Kendra, Vega, Sarah, Sally, Ariana still on the leaderboard. The point at which no more solute will even dissolve in a solution is called what? Saturation, evaporation, or concentration? Point at which no more solute will dissolve. What is that called? 20 seconds. Private chat people, make sure I get your answers. Awesome. Thank you, Sophia. Haley, see yours. Adrian, you are in the room chat. Make sure you're in your private chat. Thank you. Yes, it's going to be called saturation, right? If we say a solution is saturated, we mean that we have dissolved as much as possible into it and we can't dissolve anymore. What would all the extra stuff do? What would all the extra solute do once a solution is saturated? Tell me in the chat box. What does all of the extra solute do? Oh, awesome, Jeremy. Yeah, it'll just settle at the bottom. It'll just sit there. Exactly. You got it, guys. Kendra, Vega, Sarah, Jeremy, and Juliana. Diego has reached an answer streak. There we go. Does this make sense? Stephen. All right, so concentration increases per amount of solute. So high concentration means more. Less concentration means less. And solute will continue to dissolve until there's no more room, which is called a saturated solution. All right, here we go. Let me know if that makes sense. 15 seconds, 13 seconds. Awesome. Haley, I see yours. Zoe, make sure you let me know if that makes sense. No, Jeremy, you can do it. Awesome, guys. Cool. Love it. All right. Let's see if we can catch up to Kendra, Vega, Sarah, Jeremy, and Juliana. Solutes can be physically separated from solvents using what? Freezing, condensation, or evaporation. How do we separate these two things from each other? Think about salt water. How do we separate the salt from the water? Or sugar water? How would we separate the sugar from the water? Cool. Adrian, I see yours. Sophia, I see yours. Thank you. Zoe, awesome. No, Stephen. Awesome. Haley, I see yours. Yes, it's going to actually be evaporation, right? Evaporation is going to take what out of solution? Evaporation is going to take what out of solution? Think about water and salt. What is evaporation pulling away? Yeah, it's taking away the liquid, right? It's taking away that liquid water, right? And what's left over is going to be the solute, the solid salt at the bottom, right? All right, here we go. So Kendra, Vega, Sarah, Juliana, Sally on the leaderboard. Sienna with an answer streak. Does this make sense, everyone? Okay, so solutes can be removed from solutions by physical processes, right? We can evaporate the solvent. Our example was desalination, where we actually evaporate clean water, leaving behind the salt, all right, or leaving behind dirty water, right? 15 seconds. Evaporation allows us to take away the solvent, leaving behind the solute. All right, here we go. Increasing temperature, blank, the solubility of solid solutes. Does it decrease the solubility or increase the solubility? So increasing temperature, will more or less of solid solutes dissolve, right? Less means decreases, more means increases. Awesome, guys. Get your answers up there. Again, think about sugar and water. Think about hot drinks. Will solubility decrease or increase? Awesome, guys. It's going to actually increase. Tell me in the chat box, is it easier to dissolve sugar in iced tea or hot tea? Yeah, we just did this in our lab. So exactly, if you did our lab, you should definitely know this. Yeah, it's going to dissolve better in hot tea, which means you can dissolve more in hot tea, and so solubility will increase. Smiley faces if that makes sense. When we're talking about solids like sugar, it's going to increase. Oh no, Kim! Cool, guys. All right. Jasmine back in here. We've got Kendra, Vegas, Sarah, Juliana, Diego on the board. Increasing temperature blank the solubility of gaseous solutes. All right, so now we're thinking about gaseous solutes like carbon dioxide in soda. Think about hot soda is going to have more or less carbon dioxide in it. Does solubility decrease less carbon dioxide or increase more carbon dioxide? Think about hot soda, which is disgusting to think about. Awesome. I see Adrian's, I see Zoe's, I see Sophia's. Haley, make sure I get your answer. Yeah, it's going to actually be increases. Wait, sorry. Oh, sorry. You guys are totally correct. This is actually my bad. I'm so sorry. I don't know why this... Yeah, sorry. You guys are correct. Increasing temperature actually decreases the solubility of gaseous solutes. I'm so sorry. That is my bad, guys. No, so sad. You guys are correct, though. I'm sorry if that messed up any of your scores there. But you guys are totally correct, right? As we increase temperature, soda actually gets less fizzy, right? So it's less soluble. Okay, smiley faces, guys, if that makes sense, or answer up here if that makes sense, right? Hot tea, more sugar. Hot soda, less gas. Okay, they're opposite relationships. I have to fix that. I'm so sorry if you lost points for that. So sad. 5 seconds, and so many of you got it correct too. Cool, guys. All right, let's keep on going. Which size particles will have a higher rate of solution, or how fast they dissolve? Small, large, or medium? Which size particles have a higher rate of solution, which means how fast they dissolve? So dissolve faster. Small, large, or medium? Awesome. Sophia, Zoe, Haley, that's not an option. Small, medium, or large? 3 seconds. Yes, the small ones, exactly. The smaller particles will dissolve faster. Think about granulated sugar, just a spoonful of sugar, versus a sugar cube. Which one dissolves faster? Which one will dissolve faster, the spoonful of sugar or the sugar cube? Which one dissolves faster, the small particles or the large particles? Yeah, the spoonful, right? All those teeny little crevices allows the water to get in and to dissolve from all sides, right? Cool. Kendra, Vega, Sarah, Juliana, Diego, let's keep on going. Does this make sense? It's not over yet. What are you talking about, Stephen? So smaller particles mean more surface area. Therefore, they dissolve faster, right? It means that we can get more water into each of these little pieces, right? That's why small crystals will dissolve faster than sugar cubes. Let me know if that makes sense. It's kind of an opposite relationship where smaller particles actually allow more water to dissolve that sugar. Cool, 5 seconds. All right, awesome, guys. Here we go. Last question before we do our final wrap up. To increase the rate of solubility for sugar in water, which of the following will work? Stirring, using sugar cubes, or decreasing temperature? Which one will increase the rate of solubility? 15 seconds. Give me your answers. Yeah, Steven, you got to make sure you participate. 5 seconds. It's okay. We'll do better in the future. Yes, stirring is going to help with solubility the most, absolutely. Using sugar cubes, we just talked about this, right? The bigger the particles, the less soluble, the less the rate of solubility, right? It decreases how quickly it can dissolve. Decreasing temperature, right? Colder temperatures mean we're not going to be able to dissolve as fast. No worries, Sophia. Smiley faces, guys, if that makes sense. The only one that increases solubility is stirring. Increases the rate would be stirring. Cool, guys. And the reason that that works, we're going to go over that in a moment. Does this make sense? The reason that that works is because you're actually increasing kinetic energy, right? Stirring increases the kinetic energy, increasing the rate of solution, increasing the amount water can attack sugar. 15 seconds. Give me your answers. I know, sad baby. Sad baby. Sorry, guys. Yes, Kim. All right, looking good, guys. Awesome. Let's get our results here. Very well done. Give everyone a round of applause. We got Kendra, Lily, then Vega, Sarah, Diego, and Sally. Vega, I think, is going to have to come back and try to reclaim victory. Awesome. You guys did great. Let me go ahead and save these really quickly. And then I'm going to go ahead and come back over here, guys. Yes, next time we'll do awesome. Cool, guys. All right, here is your last word. Thanks so much for being here. Hope you guys have a wonderful day. Good review. Bye, everyone. Thank you. No, Kendra, you did awesome. Very well done.